In the given circuit, the breakdown voltage of the Z0 diode is 3 volts. So this is 3 volts. Okay, what is the value of I2? So we have to find, this is I1 and this is I2. So what is I2? Okay, so if you see, if this is 3 volts, so then the potential difference across CD is also 3 volts. So therefore the current, that is I1, we can write here, I1 is equal to 3 volts, 3 divided by 2. Okay, so this is I1, which is 1.5 milliampere. Now since this is 3 volts, so therefore the potential difference across 1 kilo ohm resistor must be 7 volts. Okay, because of again Kirchhoff's loop law. Okay, so this is 10 volts, this is 3 volts, so this must be, potential difference must be 7 volts. So therefore the current through this 1 kilo ohm is equal to 7 volts divided by 1 kilo ohm, which is 7 milliampere. So therefore 7 milliampere is I1 is 1.5 milliampere. So therefore 5.5 milliampere, which is 7 minus 1.5, which is 5.5 milliampere current must be flowing through IZ or I2. Okay, thank you. Which of the following circuits is reversed bias? Okay, so reverse bias means, so for a diode to be reverse bias, okay, this should be positive and this should be negative. Now here if you see, so this is 0 and this is positive, so this is forward biased. Okay, here if we see, so this is 0 but here it's negative, so here also it's been negative, so this is negative and this is positive with respect to it, so this is again forward biased. Here we have plus 2 volts, so this is plus 2 volt and this is negative, so again this is also forward biased. Now here we see, yes, this is plus 2 volt but here it is 4 volts, so this is having more voltage rather than this one, so therefore this is reverse bias, so therefore the answer should be 4. Thank you. Conductivity of photodiode starts changing only if the wavelength of the incident light is less than 660 nanometer. So this is a photodiode, and in photodiode what happens is, when photons are struck, so then what happens when photons are striking, so that time the electrons, they are like they come out and then these electrons move across the band, energy band, okay, band gap. So therefore if we see, then Hc by lambda is the energy of the photon and they have to cross the band gap. Okay, so now if the band gap is like which is mentioned here, x by 8 electron volt. Okay, so therefore this Hc by lambda, that means the kinetic energy of the electron should be so much that this is crossed, so therefore this should be equal to x by 8 electron volts. Now we have to solve this entire thing. Okay, so H is 6.6 into 10 to the power minus 34 joule second into C, which is 3 into 10 to the power 8 meter per second divided by lambda, 660 into 10 to the power minus 9 meter should be equal to x by 8 electron volt. So it's 1.6 into 10 to the power minus 19 coulomb into volt. Now coulomb into volt is actually joule, so therefore this is gone with this, second goes with this, meter goes with this, so now we are getting x as pure number. So this 10 here and this is 10. Okay, now here also it's 10 and this is 2, 10 and 10 are gone here. Okay, so therefore x becomes 3 by 2, so this is 3 here and this is 2 here, so therefore 3 by 2 into 10 to the power minus 34 plus 8 minus 1 plus 9 plus 19, 19 plus 9 is 28, 28 plus 8 is 36, 36 minus 35 is 1. So therefore 3 by 10 into 10 power 1. So therefore 3 by 10, 2 into 10, which is 15. So therefore the value of x is going to be 15. Thank you. The truth table of the given circuit diagram is, okay, so this is A, this is B naught, this is A naught, this is B, and this is again this is AND gate, this is also AND gate. So therefore this is A dot B bar, okay, and this is OR. Okay, so basically we have A, B, then we have A bar, B bar, then we have A dot B bar, that is A and B bar, and then A bar and B, and then we have A dot B bar and or A bar dot B, A bar dot B. Okay, so 0 0 1 1 0 1 0 1. Now let us calculate. So what is A bar? So this so 1 1 0 0, because it's going to be not of A. Okay, so not of A is A bar. Now not of B is going to be 1 0 1 0. Now A dot, yeah, A and B bar, A and B bar. So 0 1, so it's going to be 0. 0 0, it's going to be 0. 1 1, that has to be 1. 1 0, both should be 1, so 0. Then A bar and B, A bar and B, 0, both should be 1. Yes, only here it is 1, otherwise everywhere it's 0. Now OR, so 0 1 1 0. So therefore B is going to be the answer. Thank you. The truth table for this given circuit is, okay, so let us first identify this is A, and this is A bar, which is not, and this is B, this is B, and this B is also here, and this is A bar. Okay, so this is an AND gate, so therefore we have A dot B here, and we have here we have A bar dot B, and this is an OR gate. Okay, so now let us do this. So we have A, we have B, then we have A bar, we have A dot B here, we have A bar dot B here, and then we have to be, so if this is X, this is X1, this is X2, so this is X1 dot the X1 or X2, which is actually Y. Now 0 0 1 1 0 1 0 1. So A bar is going to be 1 1 0 0. A dot B is going to be 0 1 1. No, it is this is AND, so it's going to be 0, this is 0 0 and 1. Now A bar and B, A bar and B, again this is 0, no, this is 1, this is 0, and this is 0. Now X1 plus X2, so OR, so 0 1 0 1. So we should be having this B option as the answer. Thank you. A Zener diode of breakdown voltage, that is 10 volts, is used as a voltage regulator as shown in the figure. Okay, so this is the Zener diode and the voltage is like 10 volts. The current through the Zener diode is, okay, so here we can see the voltage across is going to be 10 volts. So therefore 10 volts should be the potential drop across this one. So therefore the current through this is going to be 10 volts divided by 200 ohms. So this is 1 divided by 20 ampere. This is the current, that is I1. Now 10 volt is the potential drop across 500 ohm also, because because we can see the both are connected in parallel. So therefore I3 is going to be, so this was I1, so I3 is going to be 10 divided by 500, which is 1 by 50 ampere. So since now we can see here that in this direction the current which is flowing is 1 by 20 ampere. In this direction the current which is flowing is 1 by 50 ampere. So therefore the current through I2 is 1 by 20 minus 1 by 50 amperes. So which is 100. 5 minus 2, which is 3 by 100 ampere, which is 30 milliampere. So therefore C is going to be the answer. So we have to be very clear that whenever Zener diode is there, Zener diode has a it's used as a voltage regulator, therefore it is having a constant potential difference across it. Okay, so if suppose this is the Zener diode, okay, and then let us say 10 volts, so it is always be having 10 volts only, irrespective of the potential difference applied here. Okay, thank you. So in the given circuit, the voltage across load resistance RL should be, so this is I current, so the same I actually flows like this. So by Kirchhoff's loop law, if we do, what's going to happen? So 15 volts minus 0.3 volts minus 0.7 volt, and the same current is going to pass through both of them. So minus I into 1.5 plus 2.5 kilo ohms, this is going to be equal to 0. So therefore I is going to be 14 divided by 4 into 10 to the power minus 3 ampere. Now this is 3.5 milliampere. Now the question is the voltage across the load resistance. So therefore the voltage across the load resistance is equal to I into RL, which is 3.5 into 10 to the power minus 3 ampere into 2.5 kilo ohm. So kilo is 10 to the power 3, this is gone, this is gone. So 3.5 into 2.5 volts. Sorry. So it's 2.5 into 2.5 is 6.2. Okay, we can do this. So 2.5 into 6.25, 6.25 plus 2.5, this is going to be 8.75 volts. My multiplication also will get the same thing. So we have 3.5. Okay, so this is 175 and this is going to be 700. Okay, so this is 70. Okay, so 8.75 volts. Okay, so therefore A is going to be the answer. Thank you. The output of the given diagram is, so this is A, this is NOT gate, so therefore this is B bar, then this is B, because if you see here, this is how I know, so B, so this is A bar. Now this is OR gate, so therefore A or B bar, this is B or A bar, and then this is A plus B bar plus B plus A bar, and the entire is having a bar above also. Okay, so now let us solve this. So A, B, then A bar, B bar, then this is A plus B bar, this is A bar plus B, or then there is A bar, A plus B bar, or A bar plus B. If this is X, so this is X bar, which is actually Y. So now let us do this. So 0, 0, 1, 0, 0, 1, 1, 1. A bar is 1, 0, 1, 0. B bar is 1, 1, 0, 0. A plus B bar is 1, 1, 1. A plus B bar. Oh, this is here, it's 0, and this is 1. Okay. Now A bar plus A bar or B, A bar or B. So A bar or B is 1, then this is 0, this is 1, and this is 1. Now either this should be 1 or this should be 1. So this is 1 here, 1 here, 1 here, 1 here. So now bar of this is going to be 0, 0, 0, 0. So therefore the answer is going to be C. Thank you. Identify the logic operation performed by the given circuit. So this is A bar, this is B bar, and this is AND gate. Okay, so this is AND gate, and it is NOT is also there, so therefore this is NAND gate. So A bar dot B bar, okay, and bar above also. So let us do this. So this is A, this is B, 0, 0, 1, 0, 0, 1, 1, 1. Now A bar, B bar. So A bar is 1, 0, 1, 0, B bar is 1, 1, 0, 0. Now A bar dot B bar, okay, is going to be 1, 1, 0, 0, 0. Okay, now A bar dot B bar, and there is NAND, like there is not over it, so it reverses 0, 1, 1, 1. Okay, so now if we see, this is basically A or B, because A or B is also going to be 0, 1, 1, 1. So therefore actually this is an OR gate. Okay, because we see the output is going to be the same. Okay, here the output is same as that of the OR gate. Thank you. In the given circuit, if the power rating of Zener diode is 10 milliwatt, so here this is the Zener diode, so this is I into V is equal to 10 milliwatt, which is power. So therefore we can tell I is 10 milliwatt divided by 5 volt, which is 2 milliampere. So this is how the current is flowing in the Zener diode, because the Zener diode always works in reverse bias. Then the power rating of Zener, okay, the value of series resistance to regulate the input in regulated supply. Okay, so this is 8 volts and this is 2 milliampere. Now since this is 5 volts, so therefore the voltage across this is going to be 5 volts. So therefore the voltage across this 1000 ohm is also 5 volts. So therefore the current across this is 5 divided by 1 kilo ohm. This is the current across. So therefore this is again 5 milliampere. So therefore the current across RS must be 7 milliampere. Now since this is 7 milliampere, so therefore we can also see, and this is 8 volts, so therefore the voltage drop here must be 3 volts. Thus we can see I into RS should be voltage, which is 3 volts. So therefore 7 milliampere into RS should be equal to 3 volts. So RS becomes 3000 divided by 7 ohm. Okay, this is the answer. Of course this answer it was not given, so but yes, we have included this. Thank you.